Oh. Oh.
Scan the QR code first, please. You guys can have a it's on the house. Great. Oh yeah.
Oh God.
I think we'll get a little bit more.
Yeah, we have to depend. This is a good day. Yeah, in the past, the grid is the importance there. I'm gonna see where it was. So I'm gonna the only thing. No, not the only thing. I had pizza. Oh my God. Good man. That's engineering. Yeah. This is the same. You guys know. Something 22 minutes. Yeah, and I just like, you just like look at that, I pay value. And I just I don't know. I don't really. Yeah, really happy. Oh, yeah. And then I'm trying to resolve knowing that it's good to know that. Where do you find that?
Hi. Okay.
So looking at this, I got island insurance, and then this is supposed to say BL. I don't understand why BL wouldn't be 0 because I put a voltage source here because it was charged up to 0, and so that means it would go 0 volts from the ground. So this would just be 0. So 0, 0.
Oh, I was going off of the ground. So if this is 0 volts there, then yes. BL is 0. But the way she drew it when we went through this is it was open.
Every time I've done a problem like this,
It's been that to get.
off by 1 bit.
Yeah, I'll do a.
It's like then and each time I get negative voltage, but it's only off by 1 bit. So I got negative 0.
Yeah.
Correcting to negative 1. And I've practiced it over, and I found the textbook, and I didn't see where you got this from. And
So you're doing either, I would say it's probably somewhere in your mind. We're working on 70.
probably your office hours or something.
Okay.
Thank you.
All right. Yeah. All right. Welcome, everyone. Welcome those that are online. Oh, we don't have this on. Sorry. Sorry, I have to turn on the projector. Okay, this is better. All right. Homework due tomorrow. So Thursday, homework quiz will be on Friday. Next week, Wednesday will be the exam. It will be held in the Engman lab, which is upstairs here in L210. So you're going to be using the computers up there to submit your work. So if you capture your work with your phone, feel free to bring your phone. If you don't, and then there's a scanner there, you can use the scanner to put in your work. So it will have partial credit if you do get it incorrect, but you do need to upload your work. So be prepared to work on the computers there, and then upload your work to it. Yes.
If we're working on the computers, do we use Desmos?
Yes, so you can use any online calculators that you want. They'll be accessible. what I'll have each of you do is on your screen, just put your windows that you have open next to each other and not have browsers that have, underneath them. So that's how I'll ask you to do it. So just as you do it on the computer, you're welcome to also do it online for some of you who need to do remote. Just note that if you do attend the exam online, you may have to do a validation step to that. And then so either I or the TA will reach out to you and do a validation step. So if possible, I do request that you come in person. We have that room reserved and I'll meet there. So Engman Lab upstairs in the Engman in Web 210. And so it is the lab in there. Questions about the exam? Oh, open notes, open book, open computer. So you will have access to online material if you want to look at them. Just no utilizing anything like Chegg or any other online places where you can submit the work and have somebody else solve it for you. So still required to be honest and do your own work.
And no MATLAB.
And the other thing is just no MATLAB. But I don't know, maybe I should even say MATLAB's just a glorified. In these cases, I mean, I don't even care if you use MATLAB. So, yeah, I don't even care in this one because you can't really, you have to set up your problem anyway. So if you want to use MATLAB for the calculation portion, I'm fine with that too. Whatever you prefer, you are welcome to use those online calculators though. Desmos, Wolfgram, some of the others will even solve like the algebra for you. So I don't care. I'm looking more for the concept of what you know, and being able to set up the equations and solving them. Okay. Any other questions? Content? Yes.
What about the notes? Like you said, it's open notes.
Yeah.
Like, do I have to have like one? Maybe something else. I have one side with notes and something like a calculator.
Yeah. So his question is like, how do I have if I have my online notes and I want an online calculator? So you would set up like your exam portion in the small side. Up here, maybe here's your notes, and down there would be your calculator. So just so you can see it all on the screen, just so all the windows are shown on the screen that you're using, and that you just don't have any with multiple screens on them. Does that make sense? Yeah. Okay. So as many openings or as many windows as you want, just make sure they're all tiled as one on the screen. So that's the only request. But yes, you can have multiple ones open. All right, any other questions? Okay, I guess before I get to this, then let me do a quick content of what will be on the exam. So a RC circuit solution, and then an RLC circuits, an understanding question. So exam 1 content. So next Wednesday. Okay, so RC circuit, RLC circuits, and then an understanding question. And I haven't gone through a lot of understanding questions, so I'll start to kind of probe a little bit today and on Monday of kind of what kind of questions I could ask. The other part to get more practice on those is on that Unit 1 practice problems. There'll be some understanding questions on there too. So those would be areas you can look to get kind of those questions. All right, anything else to do with the exam or what's coming up? Oh, the other thing coming up is going to be Tuesday. You're going to have do is that practice, the group practice or individual practice exam uploaded and exchange. I encourage all of you to do it early and then, look at other people's, use that also as a way of studying. So the goal of that is to give you guys practice. It makes it a little different when you have to think about creating the problem yourself and then how to solve it. Okay. So make sure you get that done. By Tuesday night will be when that will be due. So you'll be ready for Wednesday's exam. Any questions about that? Yes.
Is there still homework due next week?
So there'll be no homework. Did you see a due date somewhere? Okay.
That's why I asked.
Okay, I just want to make sure. I still have some errors here and there. So if you do see something and you're like, I'm not sure, I thought she said we didn't, reach out to me and let me know. But yes, there'll be no homework and no quiz next week because of the exam. So exam weeks will be the only week that will be a little different with having a homework and quiz.
Okay, cool.
So on that week, you'll just have that. The homework really is that practice exam that you work in a group or individually. Okay. So yeah, you'll have Thursday and Friday that you don't have to stress about that. All right. Yeah. Any other questions? Any questions online? All right. So exam coming up. I had a question about this where this one asked for in the homework to calculate VC at 0.5 micro. I'm not going to ask you to do VC. I'll ask you to do IL. So I changed that problem. So if you had that one, hopefully you just can skip it and try another one. Did you want me to still go over like how to solve this even for IL?
Actually, if you feel like I'm working through it right now. So,
Okay, what is your guys' request? Would you like me to do this one here in class? I'm seeing yes, still yes.
yeah,
Okay.
I think so.
Okay, all right, so. All right, so to find IL for this one, the switch is open and then it becomes closed. So what's our first step?
Series.
Okay, identifying is it series or parallel? Whoops. How do you determine? Okay, so how many nodes they're connected to? And where do you put the switch to determine that? Okay, good. Final stage to determine, is it in parallel or series? So this will be closed in that case. And if I want to highlight the nodes just to see, I can see that these have the same color on the top and the bottom. So they are in what? In parallel. Okay. So this would be a parallel. Now what? What's their next step? Okay, so finding RTH so that we can determine alpha and omega. So RTH. And so it will still stay in this final stage. And I'm going to remove these two and put to 0 all of the sources. So that means this becomes an open for the current source and a wire for this one. And then my A is on top and B is on bottom. So the pathways here, I can see that I have, these go in different directions out of A. Yes. I'm going to solve it symbolically. Yeah. So I'll just do symbolically. So R2 is a value given, but I'll just leave it in R2. So I'm not going to get actual values because in your homework, you're going to have different values there. All right. So RTH will be what here?
R2 series with 6 parallel with 2 ohms.
Correct. Okay. So alpha will be Okay, because I don't have values here, I'm going to tell you that they were picked to give you an overdamped situation. Okay, so alpha is one. What was alpha? And omega naught is 1 over square root of LC. So these values, you do need to know what R2 is to calculate them. So we're doing an overdamped situation where these values do come out as alpha greater than omega naught. So do make sure your values do come out that way. So overdamped situation. So we need to know IL, VL, or IL 0, IL infinity, and VL 0. Where's my page? All right, so 0 minus is where we're going to start. So determining where the switch is, and then what we do with the inductor and capacitor at each stage. I'm going to just quickly remove these and then draw them in a second. Okay, so for t equals 0 minus, it was open. This becomes a wire, and then VC becomes an open. So VC will be what? Okay, good. And then IL is what we need to find here. How do we find IL? Do what? Okay, you can see that it's a current divider. If you don't see it's a current divider, I would go back to coloring the nodes. So if I do that, I notice, okay, I only have 2 colors here, so I'm going to pick one of them to have a voltage and do node voltage from there. So if I didn't notice this was a current divider, I could do VX here and ground. So then a minus IS. So I always do node voltage out of the node I labeled. So I'm just going to put those little arrows there. So with green going down, I have a minus IS and then VX over R2 and VX over 6. And then IS is also a given value. So I can solve this for VX. And then once I get VX, IL will be VX over 6. Everybody's following? Okay. Now at t equals 0 plus, my switch is closed, and I now need to replace this with the value for that. I'll do 0 minus here. IL 0 minus. And then VC was 0. So to find VL, I don't know, can you guys just see it? Do you want me to color it? What's VL? Okay, so VL will be 0. So VL of 0 is 0. And IL of 0 will be the IL 0 minus value. So VX over 6. Again, if you don't see that, you could color these again. And you see that 0 is in parallel with VL there. All right, now infinity. Again, it's closed. This now has become a wire, and this is open. And when I color this, I notice that I have to find IL going through a lot of wires. And if I ground this, it's going to be really difficult to find IL. So this is where I suggest replacing all of this with a Thevenin equivalent circuit and solving for it, and then put in the inductor and solve for the IL going through that. So with the Thevenin equivalent, what that is doing is it's replacing that whole circuit up there with 2 elements, RTH and VTH. And then whatever I put on my A to B gives me the same current and the same voltage across it. So if I was to put the inductor here, the current going through that's generated from this complicated circuit that's narrowed down or reduced down to VTH and RTH becomes much easier to find. And that will be the same current IL going through it. I can also put 2 elements. I can put the inductor and the capacitance. And then because the capacitor becomes open sitting so long and the inductor a wire, this only becomes just a simple wire here. And so if I find VTH and RTH, I can find IL much simpler. This is just going to be VTH over RTH. So that was why I was suggesting to try to do, when you see something like this, it's like, oh, I can't, that's hard to find. See if you can simplify it down to a Thevenin equivalent. So to do the Thevenin here, it's actually not as complicated because I have independent sources. It becomes more complicated with dependent sources. So with independent sources, all I need to do is copy the circuit again. I did not know what happened there. Okay. What happened to my? I don't know. Yeah, hopefully it's. Interesting. Okay. So now I'm going to remove So to find this, I'm going to take out the 2 elements that are making it more complicated. And then I redraw everything else around it. So taking that out, why my pen's not working very well. Okay. I literally erase them. I'm going to put the switch into the final position because that's what I'm having trouble finding. So that means that's going to go to a wire. And then this is where the A position was, and this is where the B position was. So I can color it. And so now to find VTH and RTH. VTH is where the voltage is going to be from A to B now. So if I put a ground on the bottom, I need to find the value here for VTH. So I can do this a few different ways. This is going to be a different color over here. This would be a different node. So I could do node voltage with two variables. And maybe that one's less complicated. I'll try that one. I'll call that some V2. So I'll call that V2. So setting up these equations, I'm going to have two sets of equations here with VTH and V2. So I again like to put all of mine going outwards. So this would be a minus IS plus V2 over R2 plus V2 minus VTH over 6 equals 0. This node is going to have, I again like them to go out. So I'm going to do VTH minus V2 over 6, VTH minus a minus VS over 2. Some of you like to just draw one arrow and then, you could use still the pink arrow and say that that current is going in. So that would be V2 minus VTH over 6. And then you have, and you could do equals VTH minus a minus VS over 2. Those are the same equations. So whichever way you like to write your node voltage. So from here, I can set this up into a matrix form, or I can do algebra to solve them. And it's going to yield a value for VTH. RTH is going to be the pathway from A to B. And you're going to just short, meaning put to 0 the sources. So in this case, when I short VS or put to 0 VS, that becomes a short. And when I put 0 on the current source, it becomes an open. So this will be a wire and this will be an open. And what will RTH be here? Mm-hmm. Correct. So remember, it's going from the A to the B, which means in this beginning part, they split. Oh, shoot. Those arrows. So because they go in different directions, I have a pathway there and a pathway there, and they're going different directions. That split means that those two branches have to be in parallel. Okay, so then you get VTH and RTH from that, and then you can get this IL infinity. So this will be your IL infinity. And now you have all the values you need for the equation set. Then, when we worked on this, we didn't have that original, where'd it go? 0 volt source wasn't drawn in there. So that's why that VL was harder for that one. That makes sense. Okay, other questions? Any questions about these steps? Yes.
So the red nodes, why is it in parallel and not in series if the IS is or open circuit?
Right here?
It is like that. Why? I know there's an extra node there because it's the red, purple, and green, but if that's an open circuit, I'm go that's not just in series.
So R2 is in series with 6,
But not
not in series with the 2. So you physically have to put your pencil down on the A point and see where your pathways go to get back to B. If you're at that point, they have to go in different directions to get back to B. So, okay, I just say put your pencil on and see where your pathways go. If they went in series, it would only be one way to get to B. But because they go in 2 different directions from that A point.
I guess it's just weird using it never
Mhm.
one like continuous flat.
I know, and it's hard because visually they're the same color. And so I see where, so I tell students physically put your pencil down on that A node and see from there, where are they going?
You can draw the line up from A down to B. To show that, yeah.
That might help some people. Whatever helps you, just know you have to put it, like it is going to split there because your pathways are different.
So then those colors are not right.
Correct.
Yeah.
Erase that color. Oh, that was not good. Okay. I don't know if I can erase the green one, but. Yeah, so you treat that node as an extraordinary node because you are probing it. So you've added in another connection in there. I'll put that extraordinary node. Okay, other questions? Everybody followed that? Seeing some yeses now, so more clear. Okay. I'm going to do a little question here. What if I have a little different circuit? What is happening in this? Say my circuit ended up inductors, capacitors, and I get this circuit instead. And I am trying to find the current here in IL. The IL was here instead.
IL just be IS,
Yes, why?
because IS would take the path of least resistance, which would just be IL.
Yep. So if I was to color these, I actually get, this all ends up being now red down here by adding in that. So if your IL does short that current, it would just be IS. So why? Go to this one. What's the difference between this one and that one?
There's a voltage source also connected to the wire, right? In that sense, they're going to compete IS and the current from VO.
So that wire is not in parallel directly with IS, right?
Right.
There's elements in between them. And that's the difference between just the wire in parallel with IS and the circuit. So I did want to point that out because some of them may be more simple. Well, it's like that inductor is right in parallel with the current source. So all of the current has to go through the IL when it's shorted. But this case, we don't have that because this is another color up here. Okay, yes.
Alright, in that circuit that you showed me, you have the IL in parallel directly with the point source.
Uh-huh.
Why wouldn't you do like nodal analysis with VS and check for anything going into that wire? Why do we completely ignore that?
So we're not ignoring it. It's just that will have a different current going. So move these. So the current going through there is still current going through here, but it doesn't, like IS doesn't go that way because the path of least resistance is going to be to go through the wire. So IS is having IL. It's going all through there. So IL will be equal to IS in this case. This current here will be another current. And that's generated by the VS in that branch. So that VS gives you current going this way. So,
I think he's asking, why does the VS or the IX current in that branch not reach or connect to the IL, the branch with the IL?
So what's happening with R2 here? What current's going through there?
IX. Or negative IX.
No. There's no current, thank you. Yes. No current is going through there because the red is on top and the red is on bottom. So there's 0. So you can actually erase this kind of from this circuit. So this is really not doing anything there. So the ground, there's ground across IS. So IS has no voltage drop across it, but because it's a current source, it's generating current still. So that current can only go through the ground wire. So it's just in its own little loop. So the IX current is generated by the VS, and it's only going through the 6 ohms, the 2 ohms, and the VS source. Does that make sense? Can't remember who asked that.
Yeah, so I just want to make sure. If we were, let's say hypothetically, were to do nodal analysis in the problem, this would be kind of weird. Would everything kind of like cancel out and it'll still be IL?
I guess partly where would you, so the only place you could do nodal analysis on this would be at the position of this A or VTH location. Because this node here is 0. Right, because it's grounded from the ground on the bottom. So you would do, I mean, you could do a voltage there if you needed to find that. And then there would be voltage there because there's a drop across the 6 ohms. So there's a voltage drop across 6 ohms, a voltage drop across 2, and then the source is VS. Does that make sense?
Yeah.
So I was thinking that current across the short.
Mm-hmm.
I think, I mean, it's like, but Ohm's law is like I equals V over R, right? And then R on a short is 0. How mathematically, so if all the current is going through there, but that equation's undefined, how does that work? I guess I asked because when I put it into like a circuit simulator, it won't work. Like if you just put a circuit that's directly grounded.
So this is why I was saying it's hard to find when it's on the ground wire. It's really hard to find what the current is. So what is happening there is that, you know, you have all of these different branches and then it goes to one source, like one ground, earth ground, you know, say is over there. But, you know, I can have a pathway from here to there. I can have another pathway from here to there. This pathway could have 2 amps going there. This one could have 4 amps going there. What if I have a wire that combines them here and then goes there? Then that's going to be 6 amps that goes into that location. So it depends on where am I measuring on those different wires, how much current is really there. And so it becomes really complicated. And that's why I said go to the Thevenin. In this case, it's a little easier to see because like, oh, well, that wire itself can really only take. Yes, but you're right, as far as it's hard to tell. And so do the Thevenin. And that makes it easier to be like, oh, in this specific wire location, this is what's coming there. Does that make sense? Okay. Other questions? Yes.
Can we explore something real quick? Can we go to T equals 0 minus for a second? This is a capacitor, like VC of 0 minus is equal to 0 question that I have. So if we could, I don't know if this would better help answer my question, but could we change the current source to a voltage source and then move the R2 up top, just like a quick source transformation?
Yeah.
Value that I got from voltage source was 31, so we can use that as a placeholder.
Okay, it will be ISR2, whatever.
Oh,
Your,
yeah, IS2. So
yeah, whatever your values are.
at 0 minus, I'm assuming that this voltage source right here would be charging the capacitor, right? My question is like, although from the node, when we looked at the nodes and realized that it was connected to the ground, I understand that BC is equal to 0. But my question is,
Oops, sorry.
wouldn't it be charging the capacitor up to the value of ISR2?
If there was, so if only if you didn't have the inductor there.
Okay.
So if you had this circuit, that would be charging up to the ISR2 because there's no current going through the R2 and the 6. But because you have a wire there, it grounded it.
Okay. But before it was a wire, like it was an inductor, right? So would it have built up to ISR2 and then went back down to 0, or just it never went to ISR2? I guess I'm asking, like, would it have always, like, would it, I guess, yeah, like you said, it shorted it. Okay, so that,
Yeah.
I can see that then, okay.
Right as you got it out from the drawer, and then you like hook up your circuit and then you put the power on really quick, that will be a transient response right there.
Okay.
But before that transient response, there was no charge on it because it was sitting in a drawer. And then it's going to take some time. And you'll again, like, how does it transition from here to 0 again? So it goes from 0 to 0, but there'll be some transient responses in there. And so then you have to determine, because it's an RLC circuit, what is that transient response? Did it go over damped, under damped, or critically damped between the 0 and the 0?
That makes sense.
And so, yes, there's some changes in there, and it can actually oscillate, like, you know, depending on what it is, you might have a sinusoidal value seen between those 2 points of 0 to 0. And I know a couple of people ask me, well, how can you have like a negative value at a specific time when your initial is 0 and your end is 0? And that's what the interesting thing about an RLC is that it does have a transient. It can actually get a value depending on the time you're measuring it.
Right.
And so you know, it can oscillate and then go from 0 to still to 0.
Okay.
Or it may just like go up a little bit and then down really quickly, or it could go negative and then up a little between those 2 0 points. Does that make sense?
No, that actually answers. Why I thought-
Okay. All right, any other questions? Guys ready to try another problem? Okay. All right, 619. All right, go ahead and you guys work online, just in this room. A few of you each day, so. Go ahead and solve this to determine VC of T.
My first instinct when finding our evidence was like I made it into like or like I made it into a constant source.
Yes, you just transform the.
Yeah. Would I get the right solution with this?
Yeah, yeah, you can do the same thing. But yeah, this will be our two. Yeah, you can still get the same solution.
Okay, thank you.
Because I don't want to crunch the numbers. No, I'm really fan. I did it. I guess that was Actually, it actually would increase. Oh, yeah, that's what I calculated, yeah, this one you go. This is product. Now we go. Yeah, that's what I'm saying. These things are good. So that's the key. 2,000 plus.
All right, so I had a couple questions that came up about this, so I'm gonna just like tell it to everybody because other people probably have similar questions. So one of the questions was, for this IL, why can I not just do a current summation here? So as you notice, IL is gonna have I1 coming in. So this is all the same node, but at the top of that node, you kind of see like, well, I1 comes in. So if I do that as a plus, and then on the right side, I see I3 going out, but that node is the same also as here. So then I have to sum that I2 is going out from the bottom, and then IS is also going out. And then I3 is coming back in. And so I guess IL would be going out. But then IL is coming in. So everything ends up canceling. And it's like, this can't work. So this is why this was confusing.
I did that, don't know an answer.
You got how did you do it? Just IL is equal to I1 and I3?
Well, I did a source transformation to, and then put the resistors in series on top,
Mhm.
and then I treated that current going in against the current from VS. But the same confusion is still apply with yours. I guess I love you.
I mean, it might work. I1 coming in.
Minus I3, I put it is equal to.
If you cut that wire, I mean, yes, yeah, you could do it that way, actually. It's just kind of confusing. I think it's very confusing.
So my whole thing could work.
Yes, yes. So you kind of have to look at it a little differently though and say, okay, I'm kind of cutting this section out here. So it's not connected on the bottom. And I'm just like looking right there at a, which would be just I1 and I3 right there. So like my example where you're kind of converging and just bringing those two into one to the whole thing. Yeah, I guess you could. Keep working on this one.
And you would like to be like. I got negative. That is something. It's not like. It goes negative. But for like sources, like it goes the negative. Because the negative. Yeah. What she said. Like to me, that yeah, it's like so let's go like this. Yeah, so like this. Yeah.
Okay, another common question came up, so I wanted to address that. When you have an element that has, so if I had a resistor and I labeled the voltage across that resistor Vx, I would make an assumption that the current going through it is going to be going in the same direction as it is. So same thing with the capacitor here. So if I have the polarity drawn as a plus to minus, I'm going to assume that IC needs to go also in that direction of plus to minus. Okay, so for an element, you always just make that assumption if a polarity is shown in there. Okay. That will help you find the right direction for the positive and negative on that. Hopefully you guys have found that this is in series. So this is a series connection. All right, keep working. Is it raise of hands, who's finished it? Oh, a lot of you have. Okay, let's go through the solution then. Okay, so series connection. And opening up this is going to give you the RTH is what? Okay, so RTH is 500, which gives me a value of alpha of, what did you guys get? 1,000, correct? 1,000 meters per second. And omega naught, 1,000 radians. And so these are equal. So we get critically damped. All right, so we get the critically damped. You got a hint because that was on the page. But if you didn't have that on there, then you may not have known. Okay, so 0 minus, the switch is closed still. This will be an open and the wire. In this case, there's no polarity for the inductor. So I'm going to just put it where I see there's a current source. So I'm going to just put it as going down in this direction. Whatever way I arbitrarily label it here, I just need to keep the current source when I go to 0 plus that same direction. And then whatever value I call it. So in this case, hopefully you see IL is just 4 milli. And the voltage across here for VC is going to be the voltage across the 500 ohms. So VC will be 4 milli times 500. And so I draw here the source of 2 volts. And I need VC, IC, and VC infinity. So VC of 0 is going to be 2 volts. IC, okay. And then IC, I'm going to label in the same direction as the polarity for that one. So this gives me a value for IC of 0 of -4 milli. And so that's how you check that your polarity is correct on that one. For infinity, it's still open, and this is also open and a wire here. So VC of infinity is 0. And so B1, draw these down here. VC of infinity is 0. IC of 0 was -4. And VC of 0 was 2 volts. So this becomes 2 minus 0. And B2 becomes, C is 4 micro. What's micro? Thank you. -4 milli. Plus alpha, which was 1,002. And so you end up with a value of a -1,000. So VC of T is going to be 2 plus, or sorry, -1,000 T e to the -1,000 T plus 2. No, plus 0. Okay, okay, plus 0. So this would be it. And this is volts for T greater than or equal to 0. How'd you guys do? Yes, questions?
How come for IC0 it's -4? Not just 4. Isn't it going from negative to positive?
So this current goes around and will come up, which is opposite the labeling of IC.
If you label IC up,
So IC has to be labeled the same polarity as it was defined up here, which is plus to minus. So the minus side is always the arrow. So because of that polarity is why it's a negative. All right, other questions? Yes.
B2, it's edited. Be positive.
Sorry, which where?
Your B2.
My B2?
Be positive. If it was negative.
Oh, yep, sorry, it is plus. Yeah. I misread it on there. Sorry, it is plus. Yeah, thank you. I just misread it on the paper I had. All right, any other questions? Yes.
You always use 0 plus in your calculations.
So if it's obvious, like, oh, those are the same, I don't need to really redraw the circuit there. But if I'm trying to find, like here, it's trying to find like IC, I usually draw it to just confirm what the value is. So you do need to find that 0 plus to find those initial values.
So 0 plus is your initial.
Yep, 0 plus is where your initial time is. So this is where, yeah, you're going to take the initial. You use the 0 minus to get the values for the initial. Okay. All right. Any other questions? All right. We'll see you guys on Monday. Have a great weekend.
Covering that question.
Yep.
You actually brought up like that a couple weeks ago, we were working on a problem. That was the one that he brought up that was like off. But the thing is, it seems like no matter how I hack it, I still seem to get the wrong answer. And this is not it, by the way. This is not it. So so my question is like, should I just assume that maybe the question was wrong? Because I think Andrew had mentioned there might have been an error.
Yeah. So for that one that had the VC, those were wrong.
Okay. And even the value could be wrong too.
So the solution had it in, I mean, the solution had it right, but I don't know if you like integrated and
I didn't,
Did
I
it
tried to,
integrated
I
correctly.
tried to leave it at, well, I've done both, as in solving for VC and IL, like doing it with and without the integration.